All right. So 9.1 is all on recursive sequences. Okay. So anytime you hear the word sequence, guess what? It's an ordered list of numbers. So everything you just looked at on that introduction was a sequence. It was an ordered list of numbers. The terms are the numbers or the values in that sequence, and they're identified by their location in the sequence. So, in other words, if you take a look at example 1, 13 is your first term. 15 is your second term. 17 is your third term. So on and so forth. Mm-hmm. You will see this denoted as 13 would be like A sub 1. That's telling you you're looking at sequence A and it's the first term. So then 15 would be A sub 2, 17 would be A sub 3, so on and so forth. Okay? So right now, we just need to be able to identify patterns and what in the world is going on. So if I have a sequence of numbers that go 13, 15, 17, 19, and 21, what are we doing? We're adding 2. Okay. Take a look at number 2. I'm going from 4 to 12 to 36 to 108. 4 times 4 is not 12. There we go. This is times 3. Okay. Take a look at number 3. I'm going from 11 to 3 to -5 to -13. -8. Whoa, that one went kind of funky. See if you can figure out number 4.
Multiply.
That was 3-ish.
Number 4 is kind of special.
Oh, she wanted to be the first Baptist and gave us hamburgers, but she put onions on them. So I was like, ooh, I don't want this. But I ate it.
What are you talking about?
Is that Tracy?
Oh, yeah.
Somebody check carbon dioxide in this place.
I know what you're talking about. She got after school list too.
Yeah.
Oh yeah, we have to.
Anybody figure this one out?
No.
No.
Oh, come on.
Give us a hint. Give us a hint.
We just wait for you.
That jump went up 2 or down 2.
It went down 2 plus 4, -9. And I ain't figured out for that.
Where you see -9 and
-9.
So she's saying right now this went down by 2, and then it went up by 7,
that's what I'm saying.
and then down by 9, and then it went up by 16. Well, that ain't no pattern.
So what is
Yeah,
this?
so what is it?
It's times negative.
Is it nothing? Is the pattern?
No, there is a pattern here.
Isn't
it if you divide by a negative number against a negative number, it's a negative number 2, or is it?
No, negative divided by negative is a positive.
Wow.
You're not multiplying or dividing in this one. I will tell you that.
I don't get it.
So shoot, negative.
You ready for this?
Yeah, sure. Give it to us.
You ready?
What is it?
-3, that's here, minus -5, which is here,
Equals 2. Oh, it is 2.
equals 2.
See, I got 2 when I followed the last one, but I was like,
So it's saying if you use this number and subtract this number, you get the next number. So let's see if it works. -5
that number and subtract
minus 2.
So wait.
What? You write that.
So your pattern is to use the previous 2 numbers and subtract them to get my next number. So in other words, in order to get 9, I need to take 2 minus -7.
So who came up with this?
I hate you.
Well, I'm trying to tell you, the same person who created homework, they got bored.
There's actually,
trying to punch their kids.
how many of you have heard this word?
Fiber.
Fibonacci.
What is that?
While you may not know what the heck that is,
It's like some kind of
anybody heard of Fibonacci?
No.
I have.
Fibonacci is a famous mathematician.
Yeah, wasn't it like?
Well, they should have been assassinated.
He created what they call the Fibonacci sequence. The Fibonacci sequence
Sound like
always
some kind of
starts
Italian dancer.
1, 1. To get the next number in your sequence, you would add these two together. So 1 plus 1 is 2. To get your next number, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And you would continue on. This is a famous sequence called the Fibonacci.
Okay. So what's its purpose? What is we supposed to be finding with this?
So can I tell you this? Fibonacci, you know how when you look at the pretty little flowers and all the petals that are coming off of it,
No.
you know that's a sequence?
No, because I don't care about the
Nobody
flowers.
pays that.
Chapter 9 is called Spiral Growth in Nature. The sequences we're going to talk about actually appear in nature.
Just like
You probably gonna make
those
us read
sometimes
stuff
totally
totally
different.
The Fibonacci sequence creates the snail, the shell for the snail.
See,
I don't
nobody
care.
cares about that.
I don't care about no snail.
No, they eat
Listen,
snails and fruits.
I do. Let it go. All right. So, what do you really need to know and be able to do in this chapter? You need to be able to write what we call recursive sequences. Okay. A recursive sequence is a term in the sequence that are based on using previous terms. Okay. So, in other words, in order to create these equations, you need to know what happened before.
What came first, the chicken?
What came first, the chicken or the egg?
Shoot, that's a great question.
That is a great question.
What came
That
first,
suits
the man or
this.
the woman? Short. But
Man did come first.
short.
Because
I don't know. I
God
don't go to
took.
church.
I don't need.
Adam came first. God gave
And then
a
he
real
took,
to
yeah, he
Eve.
took the real out of
See, but there was a female before Eve.
Lilith.
What?
Right.
You
Lilith
said
came
you went to
first.
church.
I don't go to church, but I do. study.
Lilith came before Eve,
Okay.
but she ran away because she didn't want. They wanted to be Eve.
Okay.
Lilith. She came before Eve. She
All
wanted to
right.
be Eve.
All right. That's nothing to do with math. Let's get through math.
1 plus
Let's
1.
get through math.
1 plus 1.
Okay. Recursive rule. Okay. So you need to be able to write a recursive rule, which is an equation statement for the pattern of the sequence. Every sequence starts with what they call a seed. Your seed is the starting term of the recursive sequence that are needed to begin the pattern.
Yes.
Yes.
You're
Hello?
live.
What?
Speak
Can I
up.
get Vanessa Sanchez?
Sure.
Right.
She was nervous.
No, my speaker cuts out like that.
Oh, you didn't speak.
Even
Well, she never
when
gets
even when Miss Beverly calls. All right. So there are some things that we need to look at. General notation. A sub n is what you're going to see, or possibly B sub n or T sub n. Okay. A is literally just a variable that names the sequence. Okay. You can use any variable your little heart desires unless they tell you a variable that you need to use. So I can have sequence A, I can have sequence B, I can have sequence W. Okay. I can name it anything I want. The N, the subscript, tells me the term location in the sequence. Actually, let me extend this up.
Your location and sequence, please.
So, in other words, if I've got 2, 4, 6, 8, 10, 12, etc. Okay. What do you want to name this sequence? This is going to be sequence what? Pick a letter.
A, G.
A G. Okay.
Man, why does
This is sequence G.
Ugh.
Okay. So that means that 2 is G sub 1. That means that 4 is G sub 2. This is G sub 3, G sub 4,
And so on and so on.
and so on and so on.
My palms is it. Oh, my palms.
Let me get through this little bit here. Okay. All right. So A sub n represents a term value at a specific location. So if I gave you the sequence and I said, what's G sub 6? What would you tell me?
12.
12. It's the 6th number in the sequence. Okay. So what's my pattern here? What's happening?
It's not multiplied by 2 plus 2.
Plus 2. Okay. I'm adding 2 every time. So this is plus 2. So we're going to need to be able to come up with equations that represent this. So what I mean by that is if I'm trying to find the next term in the sequence, okay, so that would be G sub n. If I want to do that, G sub n would equal. I need to be able to write, this is supposed to be 12 plus 2, right? I would take 12 and I would add 2. But I don't want to use 12 because I want to be able to replace that with any number that I want. So I replace 12 with G sub n minus 1.
Can you explain?
Okay, so hold on. So what this means is in order to get my next term, I need to go backwards 1 step and add 2. So in order to get 8, I have to go backwards to 6, which is 1 space backwards, and add 2 to it.
Okay.
Does that make sense? So G sub n should actually equal G sub n minus 1 plus 2. I always use the number that comes before and add 2. It's G sub n minus 1 because I'm only going 1 space backward. Okay, so let me give you a different one. Hold on. Let me see if I can do this in my head. Oh, help me. I'm a what?
Genius.
A genius?
Genius.
Sure. Okay. We'll roll with that.
She a mathematician.
2, 3, let's do 5, 6, 8, 9, 1, then add 2, then add 1, then add 2. Okay. Another way to look at this, I can, let's see if this makes sense to you. A sub n equals A sub n minus 2 plus 3. So, what does it mean if I'm A sub n minus 2?
You're moving forward 2 spaces. Then
2
going back
spaces
3.
back. So if I'm trying to find this next number, this means that I have to go 2 spaces back. So 1, 2. So that would be an 8.
And then you add 3.
And then you would add 3 to that, which gives me 11.
Oh, never mind.
It's not that difficult. It just looks
Where
difficult.
can I write this example?
Use that over.
Anywhere you need to. Okay, so the sub n minus whatever tells you how many spaces to go back, steal that number, and use it.
Oh.
Okay,
Okay.
so if I use like a sub n minus 7, I would have to go backwards 7 places, use that number, and then do what I'm supposed to do. Does that make sense?
Yeah.
Okay. I know this stuff can be very confusing, so I'm trying to boil it down as much as I can here.
Dumb it down.
Okay.
Everybody get this example? We good? All right, let's see what we can do. So now I'm giving it to you in words. Let's see if we can write the equation. So it says the next term of the sequence A. So that means my equation should start A sub n. Because it's telling you your equation is A. Your sequence is A. Is equal to 3 times. So 3 times the previous term. So how many steps do we want to go backwards if we're looking for the previous term? 1 step backwards. So 3 times A sub n minus 1. I want to go 1 step backwards from where I'm at. Well, right now I'm at A sub n, and I want to multiply that by 3.
Oh.
Did that just click, or did you just get a stabbing pain or something?
Itch, bro.
Oh, I got an itch.
I think I'm allergic.
Number 2 says the pattern B. So B sub n is to multiply the previous 2 terms.
So would it be n minus 2 times 2?
Not n minus 2 times 2, but it says previous 2 terms. So he just realized that we need to go back 2 spaces. So that's A sub n minus 2. And I need to go back 1 space. So A sub n minus 1. Those are the previous 2 terms. The first one that comes and the second one before it. And then it wants us to do what? Well, it wants us to multiply. All right. Got like a cramp going on here.
Sorry.
Got a Charlie horse or
I
something?
don't know what it is, but it's a sharp pain in the back of my hamster.
It's probably
Right
Charlie.
on the
I never had one and no one wanted.
Bro,
They hurt.
I had got one walking up some stairs and broke my legs.
All right. Number 3 says the pattern U. So it's U sub n.
But we never even finished 2.
That's
done?
it.
Wow.
That's it.
So can I figure this one out?
Okay.
I think you like that.
N minus 1 plus 9.
Wrong.
Okay. So he said the previous term is 1 space back from this. So that's U sub n minus 1. And then it says plus 9.
Why say wait, all over 4 me?
I don't know. Somebody tell me, what does all over 4
Which
mean?
means u n minus 1 plus 9 over 4.
Yes. Drew says
shoot.
over 4. That means the entire thing is being divided by 4.
Wait.
Dripping. It's hard to see fours.
Okay. Last one. The next value, A. So A sub n equals 5 less than double the previous term.
Huh? Wait. 5 less than double the previous term. So
So
does that
you-
mean like
Multiply the one before it times 2 to take
Okay.
5.
So double the previous term is 2 times what comes before this. So 2 times A sub n minus 1. There's double your previous term. Okay? How do I write 5 less than that?
Minus 5.
Minus 5.
Oh,
Oh, you wouldn't put that in.
I was about to say.
No.
Yeah, I was about to say that.
5 less than. That means it's 5 lower.
Yeah.
If you put 5 minus, that's 5 subtracting that. By the way, I'm going to pass out cards tomorrow. We're going to switch seats.
Can we just make sure I sit in the front? Okay.
We can shuffle.
There's no reason to move my seat. I'm staying right where I am.
You're staying right where you are.
Technically, my seat's supposed to be behind top back, but
You good? All right.
what's the homework?
Okay, so when they give you stuff like this, they give you the equation that you're going to use, and they give you the number that you should start at. Okay, so this means that my sequence is going 25, and then some number, some number, some number. I need to be able to find those numbers using the equation. Well, according to my equation, I'm taking the previous number and doing what? Subtracting 3. So in other words, I'm going to do 25 minus 3, which gives me 22. So that is here. I then need to use my previous number, so now that's changed to 22, and subtract 3, 19. I need to use my previous number, which is now 19, subtract 3.
CC. They're beautiful. How you doing?
Excuse me, Mom.
Yes,
Do you happen to remember this young man from detention on that Wednesday that we saw? A whole day of ISS. Yes, that means nobody shot tomorrow.
Please following students at the front office, please pardon the interruption. Alexis McCorkle, Alexa Mota,
Oh, Miss Horner.
Todd Nixon, Antonio Ontiveros,
I honestly don't know him.
Adrian Perez,
He can tell me where he's from.
Ariel Reyes,
Do you know who he
Adrian
is?
Santiago Sanchez,
I don't know who he is.
Taryn Watson,
The table with
Thomas
him.
Shokin. Thank you.
Thomas Shokin. I don't remember. I don't know who that is.
Jasmine Dawson wasn't there on the day that we said.
It wasn't us then.
Yeah, it
Yo, I got my check early, boy. I got my
I
check.
know she
We
wasn't there.
did Wednesday, Thursday, and Monday. Those are the only days we've had detention. And she and I were Wednesday. And then
Miss Cross was
Miss
Thursday.
Cross and Miss Cross then. You know where Miss Cross is? She's downstairs. I'll walk him down. Perfect. Okay. Thank you. Thank you. Who was the other one for him? Yes, they did.
Yeah.
Yo, Miss Smith.
Who do you? Who was else was with Miss Cross? Was it Hathaway?
All right, so
Can I go to the bathroom right quick?
You didn't see nothing.
bring your eye down.
Pardon this last interruption. Additionally, I need to see the following students: Fernando Camacho, Chandler Downs, Winfred Greer, Isaiah Jennings, Cautious Kelly, Alasia McIntosh,
Do you have? If she's
Angel.
free.
Oliqui, Alexis Oliqui, Austin Smith, Rebecca Taylor, Stephen Vanilla, Nakari Brown, Jeremiah Burleson, Devin Burns, Hayden Kennedy, Gabby Childress,
What is this?
Charles Clark, Maisha Dancy, Luis De La Cruz Perez,
This is ridiculous. Like,
They know these people don't give a fuck.
Taquise Gordon, Winfred Greer, Brooke Hemrick, John Hernandez, Ebony Holmes, Stephen
I
Hill,
don't know what this is.
Brianna Kennedy, Josh Luther, Princess Marshall, Janisha Martinez, Alan Martinez, Joseph Mason, and Janiyah Mowbray. Thank you.
What's that for?
I have no idea. Probably people that haven't shown up to detention.
All right. So for this one, it says U sub 1 is 3. So my starting number is 3. According to my equation, what's happening? What does my equation say is happening here? What am I doing?
Multiply by 4.
I'm multiplying my previous number by 4. So this is 4 times 3, which is 12. Then I do 4 times 12, which is 48. And 4 times 48, which is
Y'all heard my name be called?
no.
No.
All right, back. I really don't know if I got access or attention.
192.
192. Okay. My next one. We're starting at 5. According to my equation, what am I doing?
Dang, a lot.
Two things.
I'm gonna multiply by 4 and add 1.
Multiplying by 4 and then adding 1. So 4 times 5 and adding 1. 21. 4 times 21 then.
That's a good one.
Plus 1.
21, that is 42, so that would be 83.
85.
It's,
And 4 times 85 plus 1.
I'm gonna get on this. Oh my God. Jesus.
She be cheating. Did you notice though? All I'm doing is replacing your a sub n minus 1 with the number. Okay? That's all you need to do. So, in other words, this one becomes 3 times, and we're going to replace this with my number. So 3 times 6 minus 11.
Oh, wait, you asked. 18, 7.
7. 3 times, now that number's 7 minus 11.
10.
10. And now my number is 10.
I don't know.
19.
19.
Wow.
3 times 10 is 30.
Take away 11.
You took one.
You only took away 1.
Hey, I was thinking
She was
that.
so confident in it though. She was
I
like,
was really
why?
thinking that. I was thinking
she's
that.
like, my answer was right.
Yeah.
Okay? So just be careful with ones like this. Okay? You've got the 7 minus 2. And here's where you replace. So we plug in -1 to start.
So did we do PEMDAS?
Yes. Or plug it into your calculator because your calculator does PEMDAS for you.
Genius.
You're a genius.
Oh, just some genius.
Nah.
Genius is Okay?
Can it be -2?
-2 times a -1 makes it a +2. 7 minus 2, and now I'm plugging in 9.
I'm gonna try to do this in my junior grade.
45.
Oh my God.
What's 2 times 9?
18.
Oh,
7 minus
11.
18? That's
Never
-11.
Never 11.
7 minus 2 times -11.
83, 13, negative. Oh, no good.
What's -2 times -11? 22 plus 7 is?
Wait, it's -22 plus positive. You know, I can.
Bro, negative and a negative makes a positive. Man. Positive plus a positive.
No, I was adding the -22 plus a positive 7.
But it shouldn't be -2
Yeah, I was.
because it's -2 and
Yeah,
-11.
okay, yeah, I'm sure.
Gotcha.
Okay.
All right, last little bit. So you've got special types of recursive sequences. The first one is called an arithmetic sequence. Patterns of addition or subtraction by a constant value. So that means that I can't have +2 and then -3 and then +2 and then -3. It has to be +2, +2, +2, +2, +2. Okay, it cannot switch up. that number that you find that you add or subtract each time is what we call the common difference, and that's D. So anytime we write a recursive rule for an arithmetic sequence, it's A sub n equals A sub n minus 1, and it's going to be plus or minus, depending on whether it's going up or down, your D value. So you always take the number that comes before and either add or subtract to get your next number. So if you look at example 1, I'm telling you that it's arithmetic, which means that you need to add or subtract to get my next number. What am I adding or subtracting each time here?
I thought it was pronounced arithmetic.
Listen. You know how they like to change the pronunciation of words.
Yeah, it's not the same.
Right.
It's weird.
I want to go to the theater.
like laboratory. I can't say.
Laboratory?
Yeah, yeah.
Laboratory. Yeah, that's what I thought.
Other places they call it laboratory.
Tomato, tomato.
Right.
Potato.
That's right.
And I'd rather call it a bathroom laboratory. I mean, shower.
All right, man.
What's happening?
One knows.
What is my D value? All right, Drew. I'm done with you, Drew.
I don't know. Oh, the common difference.
My common difference. You want the easy way to find this each and every time?
Yes.
Subtract the thing.
17.
If you take your second number and subtract your first number, so what's 42 minus 25?
17.
Your life.
That's your common difference each and every time. Or you could have taken 59 minus 42 or 76 minus 59. Pick any number you want and subtract off the number that comes before it, and that gives you your common difference. So my recursive rule here then would be A sub n equals A sub n minus 1, and it's going up, so it's plus 17. Okay, so again, to find your common difference for example 2, you would take any number you want. So I'm going to take 8.5 this time. What do I need to subtract from 8.5 to get my common difference?
5.9. No. 11.
The number that comes before it. So we subtract 11.1. What does that give me?
2.6.
Negative 2.6.
Get on my level.
Okay.
Keep going.
So that means A sub n equals A sub n minus 1 minus 2.6 because my pattern is going down. Finally, the last one. Again, I can take 15.81. Actually, let me extend this for a minute so you can see. 15.81, and I can subtract off 12.43.
3.38.
And you get 3.38.
What she want y'all for?
Hold on. Can we finish this first?
Yeah.
Still recording.
Okay. So A sub n equals A sub n minus 1. And this time it's a positive number because it's going up. So it's plus 3.38. Okay.
Miss Rector came to me tardy one day, and I had to go up.
Okay.
Oh, I think
Chill. No, we've got to go through geometric here. Real fast.
Come on.
Real fast. We're almost done. Okay. The last one is a geometric sequence. So arithmetic is adding or subtracting. Geometric is going to be multiplying. Okay. Or technically dividing. But dividing is the same thing as multiplying by a fraction. Okay. And this time, instead of calling it the common difference, it's now called the common ratio. So your recursive rule for these ones will always look like A sub n equals R times A sub n minus 1. So you're always multiplying your previous term. Just like common difference, I could take my second term and subtract the first term. I've got an easy way to do this too. Second term, but this time divided by the first term will give you your R value. So 15 divided by 3 is 5. So this is a sub n equals 5 times a sub n minus 1. Example 2. Again, I can take 98, and as long as I divide by the number that comes directly in front of it, so this time 56, you can find your R value.
1.75.
1.75. So, again, a sub n equals 1.75 times a sub n minus 1. And this one, I can do 9, and as long as I divide by the number that comes directly before it, 0.5. So a sub n equals a sub n minus 1. Whoops, sorry, 0.5 times a sub n minus 1. Question?
No.
Okay.
Wait, what's wrong?